Good morning, Year 4, and welcome back to another week of maths. We're going to start a new topic in maths today, and it's all about data handling. And your first Can I title is Can I understand and interpret data? But there are words in there that we don't necessarily usually use in our everyday life. So let's have a look at what they mean. To interpret something just means to make sense of it. And data just means information. So what this is really asking you is, can you understand and make sense of information? What kind of information? Well, let's see. Information or data can be shown in lots of different ways. And you will have seen several of these before. These are all different charts and graphs that you can use to present information in an easy to understand way. Let's have a look at each one in turn. First, we have the bar chart, named because it's just made up of a lot of bars. And so in a bar chart, you have different options along the bottom, and you have your scale up the side. That's the set of numbers. So you have that up the side. Sometimes you have a key at the bottom to tell you what each different color is. And then the different size of the bars shows you how many. So you can see the one that's the most is the tallest bar. Now, bar charts don't always look exactly like this. Sometimes they might look like that. Sometimes the bars go sideways, but that's okay. It still shows the same information, just from a slightly different angle. The next one is a pictogram, and a pictogram is made up of pictures. And it looks a lot like a bar chart in the same way that the longest line of pictures will show you the amount that's the most, in the same way that the longest bar does in a bar chart. But sometimes in a pictogram, each picture represents a certain number of things. So on Monday here, having 5 cupcakes doesn't necessarily mean that the answer is 5, because if we look at the key here, it tells us that each picture represents 6 cupcakes. So that's 6, 6, 6, another 6, and another 6. So what we've got there is 5 times 6. So actually that's 30 cupcakes. So you have to be careful with pictograms. Next, we have a pie chart. And it's called a pie chart because it looks like slices of pie. And this one is all about methods of traveling to school. And you can see the different options again in a key at the side, telling you what each color is. And then the bigger the slice of pie, the more popular that thing is. So the light blue here is the smallest result. So fewer people go to school by train than any other method. And the most popular ones are the bigger slices of pie. So the red and blue here, which would be car or walking. So that's how a pie chart works. Now, pie charts are great, but they're quite difficult to make. You need a lot of understanding, and you need to know how to use a protractor. So we don't recommend that yet. You'll learn that more in Year 5 or Year 6. For now, we just learn how to interpret them, how to make sense of them. I've put these two on the same page because they're almost identical. This one here is a tally chart, and this one is a frequency table. But can you see how similar they are? A tally chart just keeps tabs on how popular something is or how many of something there is by using marks. And you do individual marks like this until you get to the 5th one where you make a gate. So you know that each gate is worth 5. Tallies make things really easy to count up afterwards. The difference with a frequency table is that it has the tally column in the same way that the tally chart does, but it also has a total column, so that you can work out the total number of each thing, and it makes it even easier to read. Here we have a line graph. Now, line graphs might be fairly new to you, and we'll study them a lot more later in Year 4. But for now, let's just see how it works. So a line graph is mostly used for when things change over time. So here, for example, you have the average temperature in Westhall by month. So if you look along the bottom, they've got the different months starting from January all the way along. And then for each month, they've labelled the average temperature. So you've got your scale up the side, and they've marked each one. And instead of drawing a bar for each one to make a bar chart, what they've done is they've just put a little cross where the result goes, and they make a line by joining each one with the next one. And that's a line graph. Okay, so now we've looked at reading the charts and understanding what they are. Let's think about interpreting them, making sense of them. So this bar chart tells me how many star jumps each person in this family can do in 1 minute. I'm going to show you some questions and see if you can work out the answers by interpreting, making sense of the information. So here are the questions. I want you to pause the video and see if you can answer each one, and then we'll go through them together. Right, let's go through these. So question 1 says, what does this chart show? Well, I kind of told you the answer to that one already, didn't I? So it shows how many star jumps each person can complete in 1 minute. And it's the title at the top that helps us to understand that. It's really important that charts and graphs have a title to tell us what they're showing us. Question 2 says, who did the most star jumps? Well, if we're looking for the most, then with a bar chart, we're looking for the longest bar. So whose bar was the longest? Well, it looks like Ben's bar is the longest because he did 72 in 1 minute. Question 3, who did the fewest star jumps? So if we're looking for fewest, that's the same as least. So we're looking for the smallest amount. Who did the fewest star jumps? Well, the smallest bar is Nan. Looks like Nan did 23, which I think is still pretty good for a Nan. Question 4 says, what makes this chart easy to read? Now, there are lots of different answers for this. Firstly, there are the numbers up the side that help us to understand it. But secondly, this person who's made the bar chart has actually written the numbers at the top. So we don't have to work it out. So the numbers are above, so we can see straight away how many star jumps each person did. You might have also said that the colours are different on each bar. If all the bars were the same colour, they might all kind of blend into one. Whereas when they're different colours, it makes it really easy for us to see who is who. You might also have said that there are labels. So along the bottom, it's labelled with each person's name. That helps us to understand as well. Okay, question 5 says, why doesn't the scale go up in ones? If we look at the side, this is what we mean by the scale, the numbers that go up the side of the chart. And here it goes up in tens, although there is a mark, if you look closely, every 5. So that would be 5, 10, 15, 20, 25, 30, etc. And the chart goes all the way up to 80 because, of course, Ben did 72 star jumps. So we need to make sure that the chart goes above 72. But then why doesn't it go up in ones? Well, think about the squares in your maths book, for example. If I asked you to draw a bar chart in your maths book where the scale goes up in ones, but your biggest result is 72, you would need 72 squares. That would be a really, really tall bar chart. And we don't need it to be that tall because we can count up in different numbers, and that makes the bar chart a much better and more reasonable size. The most important thing is that the scale at the side goes up in the same number each time and by the same distance each time, because otherwise your bar chart will end up looking a little bit wonky. This is a different type of bar chart, and it shows us multiple bits of information, so more than one bit of information in one bar chart. That's why it looks a little bit more complicated. So this chart shows us, as we can tell from the title, the amount of vegetables sold at Frank's farm stand. And if you look at the key at the side, you'll see that the blue bars tell us how much was sold on day 1. So you've got the different vegetables here, and each one has a blue bar. That shows us how many were sold on day 1. The red bars show us day 2, and the green bars show us day 3. So we've got 3 days worth of information here all on one chart. Again, I'm going to show you some questions that I want you to think about. Now, you don't have to write these answers down on paper, just have a think about it. And if there's someone at home with you, maybe have a talk about it with them and explain your answers. So here are your questions. Pause the video and see how many of them you can answer. Here we go. So question 1, which vegetable was the least popular on day 2? So least popular means it didn't sell very many. So we're looking for the smallest bar, and we're looking for the smallest bar for day 2. What colour was day 2? Let's look at the key. Day 2 is red. So I'm looking for the smallest red bar. Well, I think it looks like this one here. So which vegetable was the least popular on day 2? Carrots. Question 2, which day was the best for selling zucchini? So we need to find zucchini along the bottom. Here it is. And we've got 3 bars, day 1, 2 and 3. Which day was best? So if we're looking for the day it sold the most, we're looking for the tallest bar. So the best bar was the blue one. That's the tallest bar. So the blue one is day 1. Question 3. Approximately how many pounds of squash did he sell on day 1? Now at the side here, it tells us that it uses pounds sold going up the side. Now that doesn't necessarily mean money. A pound can also be a unit of weight. So our question says, approximately how many pounds of squash did he sell on day 1? So I need to find squash, that's here. I need to find day 1, which is the blue bar. And I need to find out approximately how many pounds. Now, approximately just means roughly. So we're estimating here because the blue bar doesn't go straight to a number at the side. It's more than 30, but it's less than 40. So we need to estimate what it would be. I think probably if you answered 31 or 32, that would be a good estimate. And the final question for this chart is which vegetable was the best seller on day 3? So if we're looking at day 3, remember that's green. So we're looking at the green bars and which vegetable was the best seller. So which one sold the most? So let's have a look. The green bar that's the tallest seems to be this one here. It's much taller than all the others. So that vegetable was corn. Well done if you got some of those. I know that bar chart is a little bit trickier to understand. Here we have a pie chart and our title tells us that this is children's favourite animals. And the options we've got are dog, parrot, hamster or cat. Again, I'm going to show you a few questions. I want you to pause the video and have a think or a talk about what you think the answers are, and then we'll go through them together. Right, let's have a look at those answers. So question 1 is which 2 animals received the same number of votes? Now in a pie chart, remember, the slices are bigger the more people vote for them. So if you've got 2 animals that received the same amount of votes, that means the pie slices should be the same size. So on our chart here, we can see that the green and the blue sections are the same size. So we come to our key and we can see that that is dog and cat. Question 2 says, which animal did half of the children vote for? Well, if half of all the children voted for an animal, then half the pie should be the same colour. And that's right, it's yellow, which means that half the children that were asked voted for hamster as their favourite animal. An interesting choice. Question 3. Which is the second favourite animal? So not the largest slice of pie, but the second largest. So what was the second favourite animal? Well, this one, hamster, as we've said, was the biggest. That was the most popular. This section is the next biggest. So the red one is parrot. So a parrot was the second favourite animal. Question 4 is a little bit different and a little bit trickier. If 20 children were asked in total, How many chose a parrot as their favourite? So if the whole pie is 20 children, we need to find out how many children would make up this section here. Well, we've already said that hamster is half of the pie. And then parrot, if you look, is half as big as hamster. So if you split the hamster one in half, you would get the same size as parrot. So let's start from the beginning. Hamster is half of the pie. So if 20 children were asked, half of them said hamster. And what's half of 20? 10. So 10 people said hamster. And if parrot is half as big as that, then that's half of 10. So what is half of 10? Yeah, it's 5. So if 20 children were asked how many chose parrot, well, 5 children chose parrot. Right, my last set of questions for this video are all about a pictogram. So here we have a pictogram that shows us how many cars drove past our school each day. And again, we've got the labels to tell us which day is which. And we've got a key to tell us how many cars each picture represents. So remember, each circle is 10 cars. So then sometimes you've got half a circle. Well, if you've only got half a circle, how many cars does that show us? Yeah, it shows us half of 10, which is 5. Right, let's look at the questions. Again, pause the video and work out as many answers as you can, and then we'll go through them together. Right, the first question was, on which day did this person see the most cars? So again, like on a bar chart, if we're looking for the most, it means we're looking for the biggest bar or the longest line. So if we have a look at our 5 days, the longest line is Monday. On Monday, they saw the most cars. Question 2 says, how many cars did they see on Thursday? So we look for Thursday, which is here, and we have this line of pictures. So we've got 2.5 circles. Does that mean 2.5 cars? No, that can't be right. Remember, each picture is worth 10 cars. So this circle here is 10 cars. This one here is 10. And this half a circle, remember, is 5 cars. So how many cars did they see on Thursday? 10, 20, 25. And the last question says, on Saturday, they saw 40 cars. How many circles would they need to draw? So if they were adding an extra section to their chart here, showing how many they saw on a Saturday, then how many circles would you need for 40 cars? Well, if each circle is worth 10 cars, then that's 4 circles, isn't it? 10, 20, 30, 40. So that's 4 circles. Well done if you got those. That was a lot of questions today. Let's have a look at what I'd like you to do in today's lesson. If you go to Google Classroom, you will find 4 different sheets, and they each look like this. So each one is a different type of chart. We have a frequency table, we have a bar chart, a pie chart, and a pictogram, all about cupcakes. What I'd like you to do is have a look at all 4 of those charts and the questions underneath. And I want you to choose some of the questions to answer. You don't have to answer all of them. There are 20 questions in total. I mean, you could challenge yourself to answer all 20. That would be brilliant. But you could just pick and choose a few questions for each chart and see if you can work out the answers. That would show really good interpreting skills, making sense of all of this information or data. Good luck today. I hope you're able to find out lots of information, and I'll see you again tomorrow. Bye.